Welcome to our deep dive into the fascinating world of time theories. Time, that relentless river seemingly carrying us from cradle to grave. But what if I told you that our everyday understanding of time as a linear progression might be an illusion? Today we'll explore some of the most intriguing ideas that have shaped our understanding of time, from the mind-bending realm of relativity to the perplexing world of quantum mechanics. Buckle up as we're about to embark on a journey that will challenge your perceptions and leave you questioning the very fabric of reality. Before Einstein, time was considered an absolute, ticking away uniformly throughout the universe. People believed that time was the same for everyone, everywhere, and that it flowed at a constant rate, unaffected by anything else in the cosmos. But then came the game changer, Einstein's theory of relativity. This revolutionary idea transformed our understanding of time and space, showing that they are interconnected and dynamic. Imagine two clocks, one stationary and the other moving at incredible speed. According to relativity, these clocks would not tick at the same rate. Relativity tells us that time actually slows down for the moving clock relative to the stationary one. This effect becomes more pronounced as the speed of the moving clock approaches the speed of light. This phenomenon, known as time dilation, isn't just a theoretical concept. It's a real effect that has been observed and measured in numerous experiments. It's been experimentally verified countless times. For instance, scientists have flown atomic clocks on airplanes and found that they tick more slowly compared to clocks on the ground. GPS satellites, for instance, have to account for time dilation to function accurately. These satellites orbit the Earth at high speeds and experience weaker gravitational fields, both of which affect the passage of time. The faster an object moves, the slower time passes for it. This principle is crucial for the accuracy of GPS systems, which rely on precise time measurements to determine positions on Earth. This mind-boggling concept arises because, according to Einstein, space and time are not separate entities but intertwined, forming a four-dimensional fabric called space-time. This fabric can be stretched, compressed, and warped by the presence of mass and energy. And just like the surface of a trampoline warps under the weight of an object, space-time curves under the influence of gravity. This curvature affects the paths of objects and the flow of time. This curvature of space-time is what we perceive as gravity. Massive objects like planets and stars create deep wells in the fabric of space-time, bending the paths of nearby objects and slowing down time. Massive objects create a deeper gravitational well in space-time, causing time to slow down in their vicinity. This effect is so significant that it has to be taken into account in technologies like GPS and in understanding the behavior of objects near black holes. So, time, as we experience it, is not a universal constant, but a relative concept, dependent on our motion and the gravitational field we inhabit. This realization has profound implications for our understanding of the universe and our place within it. It challenges our intuitive notions of time and invites us to explore the cosmos with a new perspective. If you thought relativity was strange, wait till you delve into the quantum realm, where the very nature of time takes on a whole new level of weirdness. Here, the rules that govern our everyday experiences seem to break down, giving way to a world that defies our conventional understanding. In the quantum world, particles like electrons don't behave like tiny billiard balls, but rather like waves spread out over space and time. These particles exist in a state of superposition, meaning they can be in multiple places at once, only collapsing into a single state when observed. Their behavior is governed by probabilities, meaning we can't know with certainty where a particle is or how fast it's moving until we measure it. This probabilistic nature is encapsulated in Heisenberg's uncertainty principle, which states that the more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. This inherent uncertainty extends to time itself. In the quantum realm, time doesn't flow in a smooth, continuous manner as we experience it. Instead, it can be thought of as a series of discrete moments, much like individual frames in a film reel. In quantum mechanics, time is not a smooth, continuous flow, but rather a series of discrete moments, like frames in a film. Each moment is distinct, and the transition from one to the next is not as straightforward as it seems in our macroscopic world. And just as a film can be played backward or forward, some physicists believe that time itself might be reversible at the quantum level. This means that under certain conditions, the direction of time could potentially be flipped, allowing events to unfold in reverse. Imagine the implications. The possibility of influencing events in the past or future, blurring the lines of causality as we know it. This opens up a realm of possibilities that challenge our very understanding of reality, suggesting that the past, present, and future might be more interconnected than we ever imagined. The quantum realm invites us to rethink our concepts of time and space, urging us to explore the boundaries of what we know and venture into the unknown. It is a realm of uncertainty, but also one of endless potential and discovery. As we continue to delve deeper into the mysteries of quantum mechanics, we may one day unlock secrets that could revolutionize our understanding of the universe and our place within it. The journey is just beginning, and the possibilities are as vast as the cosmos itself. Chapter 3, Eternalism. All moments exist at once. Let's step back from the mind-bending world of physics for a moment and delve into the philosophical realm. Here we encounter ideas that challenge our everyday understanding of reality. Eternalism, a concept championed by ancient Greek philosophers and revisited by modern thinkers, proposes a radical idea that past, present, and future are all equally real. This notion suggests that every moment in time exists simultaneously, much like different locations in space. Imagine a vast cosmic tapestry where every moment in time, from the Big Bang to the end of the universe, is woven into its fabric. Each thread represents a moment, and all these threads coexist, creating a timeless masterpiece. In this view, time is not a river flowing from past to future, but rather a dimension like space, where all moments coexist. Just as we can move in different directions in space, eternalism suggests that all points in time are equally accessible. This implies that our perception of time as a linear progression is merely an illusion, a product of our limited consciousness navigating this eternal, unchanging block of space-time. Our minds are wired to experience time sequentially, but in reality, every moment is already out there, waiting to be perceived. Think of it like a book. When you read a story, you experience it page by page, but the entire narrative exists all at once within the book. Similarly, eternalism posits that our lives are like stories in a book, with every event already written and existing simultaneously. This perspective can be both comforting and unsettling. On one hand, it suggests a kind of permanence to our existence, where every moment we cherish is forever preserved. On the other hand, it challenges our sense of free will and the idea that we can change our future. Whether you find eternalism inspiring or disconcerting, it undeniably offers a profound shift in how we understand our place in the universe. It invites us to see time not as a fleeting resource, but as an ever-present dimension, rich with every moment that has ever been or will ever be. Chapter 4, Presentism, Only the Now is Real. Now let's consider a contrasting philosophical perspective, presentism. This view asserts that only the present moment is real. The past is gone, vanished into the annals of history, while the future remains unwritten. In this framework, time is not a dimension we can traverse, but rather a constantly shifting spotlight, illuminating only the now. While intuitively appealing, presentism faces some challenges. For one, it struggles to explain our experience of remembering the past or anticipating the future. If those moments are not real, how can we interact with them in our minds? Chapter 5, Block Universe, Time as a Dimension. Let's return to the realm of physics and explore a theory that aligns with the eternalist perspective, the block universe theory. This theory proposes that the universe is a four-dimensional block, with time as the fourth dimension. Just as every point in space exists simultaneously, so too does every moment in time. In this view, the past, present, and future are all equally real and fixed like points on a map. We experience time as a flow because our consciousness is confined to move along a particular path through this block, much like a train traveling along a pre-laid track. This implies that free will might be an illusion, our choices predetermined by our fixed trajectory through space-time. Outro Time's enigmatic embrace. Thanks for joining us on this journey through time. We've explored groundbreaking theories that challenge our everyday perceptions and reveal the profound mysteries surrounding this fundamental aspect of our reality. From the relativity of time to the bizarre nature of quantum time, from the philosophical debates of eternalism and presentism to the mind-boggling concept of a block universe, we've only just scratched the surface of this endlessly fascinating subject. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content. Leave a comment below with your thoughts on these theories or any other time theories you find intriguing. Perhaps together we can unravel the enigmatic embrace of time.